All right, let's talk about the absolute heart of Java and really all of object-oriented programming. We're diving into classes and objects. These are the concepts that let us build powerful, clean, and manageable code by modeling the real world.
So instead of just throwing a bunch of definitions at you, let's start with a real-world programming problem. This is a challenge that's going to show you exactly why we need a better way to structure our code.
So here's the setup. You've got a file full of city coordinates, just X's and Y's, and your job is to write a program that simulates dropping a bomb and figuring out which of the cities are inside the blast radius. Seems simple enough, right? Well, how you decide to store that data? That's where things get interesting. Now, one way you could do this is with something called parallel arrays. So you'd have one array just for the X coordinates and a totally separate array for the Y coordinates. And look, it kind of works. To find a city, you'd have to say, okay, grab the item at index 5 from the X array and match it with the item at index 5 from the Y array. But it feels clumsy, doesn't it? The only thing linking a city's X to its Y is that they happen to share the same index. It's fragile, it's just asking for bugs. There's got to be a better way to do this. And you guessed it, there is. The solution is the big idea behind object-oriented programming. Instead of keeping related pieces of information in separate buckets, we're going to bundle them together into one neat logical package. And that all starts with the idea of a blueprint. That blueprint is what we call a class. Now think of it like this. A class isn't the actual thing, it's the plan for the thing. It's the architect's drawing of a house. And that blueprint defines two really important things. What the house is, like its number of rooms or its color, which we call its state, and what you can do with the house, like open doors or turn on lights, which we call its behavior. Let's use a different analogy. An iPod. A class is like the master blueprint for an iPod. That single design document says that every single iPod will have a state, things like a current song, a volume level, and it'll have a set of behaviors, like the ability to power on or skip a track. Now, the blueprint itself can't play any music, right? But it contains the complete design for something that can. So, what do you call the actual thing you build from that blueprint? Well, that's an object. An object is a real, tangible instance of a class. It's not the plan anymore. It's the actual iPod in your hand, built following that master design. And this is where the magic really happens. From that one iPod blueprint, you can stamp out millions of unique iPod objects. Sure, they all share the same basic DNA. They can all play music, they can all adjust the volume, but each one has its own separate, unique state. My iPod has my songs and is set to volume 17. Your iPod has your playlist and is set to volume 9. Same blueprint, different objects. Okay, enough with the analogies. Theory's great, but let's see what this looks like in actual Java code. We're going to build our own blueprint, a point class, to finally go back and solve our city problem the elegant way. First up, the state of our object, the data it needs to hold. In Java, we store that state in variables we call fields. For our point object, the state is pretty simple. It just needs to know its X coordinate and its Y coordinate. And the crucial part is, every single point object we create will get its own separate copy of these fields. And here's what that blueprint looks like in code. It's really that simple. We use the class keyword and give our new blueprint a name, point. Then, inside the curly braces, we just declare the variables that will make up its state, an integer for X and an integer for Y. And just like that, we've defined a brand new type of data for our program. So that's the data, the state. What about the behavior, the things our object can do? Well, in Java, we define behavior using methods. You can think of methods as functions that are bundled right inside the object, and they're built to work with that object's fields. For instance, we could give our point object a translate behavior. This method would be a function that takes in a change in X and a change in Y, and its whole job is to modify the object's own X and Y fields. It lets us move the pointer on the map. This brings up a really important question. How does an object get its starting values when it's first created? For that, Java has a special kind of method called a constructor. A constructor is easy to spot. It always has the exact same name as the class. And its one and only job is to run automatically when a new object is being created to set up its initial state. All right, we have our point blueprint. It's got fields for its state, methods for its behavior, and a constructor to get things started. So now, let's put it all together and see how this new tool gives us that clean, elegant solution to our city bombing problem.
So remember those clumsy parallel arrays? Forget them. With our new approach, we just create a single array that's designed to hold point objects. We read the coordinates from our file, and for each pair, we create a new point object. Then we can just loop through our cities and ask each point object, hey, how far are you from the bomb? And just look at how clean and intuitive the code becomes. It almost reads like plain English. For each city in our list of cities, if the bomb's distance to that city is less than or equal to the radius, do something. The logic just makes sense because we've bundled the data, the coordinates, and the behavior, like calculating distance, together into one logical thing. That's the power of objects. Now, as you start writing your own classes, there are a couple of classic rookie mistakes that almost everyone makes at first. So let's go over them right now to save you some headache and help you write solid code from day one. Take a look at this code for a constructor. Something is definitely fishy here. Actually, there are two big problems. Take a second. Can you spot them? Okay, you got them? First mistake. A constructor never has a return type, not even void. The second you add void, Java just thinks it's a regular method that happens to share a name with the class. And the second mistake, the big one, is that the assignments are completely backward. We want to take the values coming in init x and init y, and assign them to our fields x and y, not the other way around. All right, here's another super common one. This translate method, it looks right, but it's got a very sneaky bug. What do you think happens when we redeclare int x and int y right inside the method like that? This is a classic bug called variable shadowing. By writing int x inside the method, you're not changing the object's x field. You're actually creating a brand new temporary variable that also happens to be called x. This new variable hides or shadows the real one. So all your math happens on this temporary variable, and then poof, it disappears when the method ends, and the object's original x field is never even touched. The fix is simple. Just don't redeclare it. Use the field that already exists. And finally, here's a pro tip that'll take your code to the next level: encapsulation. It's a simple idea. Protect your object's data. You do this by marking your fields as private. This means that code outside your class can't just reach in and change the object's state whenever it wants. It forces all changes to go through your methods, which gives you, the creator of the class, complete control. It's a fundamental practice that leads to way safer, more predictable code. So at the end of the day, that's what a class is. It's a blueprint that gives you the amazing power to create your own data types. We started with a messy problem with coordinates and ended up creating our own custom point type that made the solution elegant and obvious. You now have the basic tool to model literally anything: a bank account, a student, a playing card, you name it. The only question left is, what are you going to build next?